this session, we will discuss about different dimensions of machine learning and deep learning, along with different types of data sets which we can use for our research work. Whenever we work on some research topic, on some particular research project, fetching and loading of a particular data set is one of the key segments. As you can see in this presentation, there are three components, three segments of research. Either we work in academic domain, or corporate, or social application. You might have seen whenever we work on some research project related to data science, machine learning, deep learning, or artificial intelligence, we have to take a specific data set, and it is one of the key points of final prediction. You might have seen, for example, we are working on some medical data set, and we are working on X-ray images or MRI images, CT scan, ultrasound. So one of the key parameter is that from where we can get these data sets, which type of data sets are applicable. So as you can see in this slide, different key requirements, which are the major requirements in any implementation. What is layered approach, with different phases that we have to work with. First point is benchmark data set. Whether you are working in deep learning, generative adversarial networks, 1D, 2D convolutional networks, CNN, or traditional supervised learning or unsupervised learning, if we are not having a proper data set, then it becomes very problematic in middle or at end of the research implementation. Many times the research scholars or academicians collect their own data set. So we will discuss about each of these points with some real-time links which we can use. So first point is benchmark data set. Many times researchers collect their own data set. So first of all, we should be clear whether these types of data sets are valid or not. For example, I'm working in X-ray images. My research topic is prediction of some particular disease in X-ray images or in CT scan images. For this type of research work, if I collect data from AIMS, from PGI, from Lal Path Lab, or from some medical laboratory, whether this data set is suitable or not, whether this data set is applicable or not. Kindly respond in chat. What do you think? For example, I'm working on some research project that is academic research project. Academic research project means MTech, ME, or PhD. I have taken some X-ray images or ultrasound images from AIMS or from some medical lab. Will it be acceptable or not? Kindly respond in chat so that we can discuss about it with some examples. Many times you might have seen people adopt this strategy, collection of own data set from hospitals, from different medical labs. Are these suitable or acceptable or not? Kindly write in chat, yes or no, or acceptable or not acceptable, for PhD level, for academic research. Self collected data, whether it is acceptable or not. Any reply you can give in chat, depend as per your previous knowledge or previous exposure. Or if you don't know, then you can write not confirmed. Self collected data for academic research. Is it audible? Is it audible to all of you?
Yes, sir.
Are you getting audio clear? Okay. Is it audible to all of you? Kindly write in chat.
Yes, sir.
So in between the session, we will interact with some queries. So I request all participants to kindly respond. Okay, so anyway, I'm replying to this point that in case of academic research, if we are working in academic domain means for master's level degree or for doctorate level degree, if we collect our own data set from any source, it will not be found, it will not be acceptable. In case of academic research, we have to work on benchmark data sets. So this is the key point. Collection of benchmark data set from where we can take different types of X-ray images, from where we can take some satellite data, or if we are working in agriculture domain, then how to collect that particular data. After collection of that particular data set, we have to move ahead on data cleaning. This is another point. After collection of data set, we have to clean it. And along with that point, we have to work on feature extraction, key feature extraction from that particular data set. And once data set is collected and it is processed along with feature points extraction, then we have to see which particular programming framework is suitable, whether we should go for Python or R or Julia or Node.js or cloud-based application. So these are different phases. And after that, analysis of models. Which type of model will be suitable for that? Okay, so now we will see different data sets. So you can see here for machine learning or for data science, we can collect data sets from these sources. You can see here on this screen, IEEE-dataport.org. Okay, until and unless we work on proper benchmark data sets, we can't get higher degree of accuracy. Definitely, if we are working on some project related to machine learning or deep learning, we have to achieve highest level of accuracy. In case of deep learning, we move ahead to 98%, 99% or more than 99% accuracy. In case of machine learning, 80%, 85%. In this particular type of accuracy level, we can be satisfied. So it depends on the domain, whether we are working on machine learning or deep learning, and where to collect these data sets. So you can see data sets related to recent domain and in multiple segments. So you can see here, if we are working in this particular disease, so you can see fake news data sets, CT scan data sets. Is it visible to all of you? In chat, kindly confirm. So you can see chest X-ray data sets. So this is main point of the research, that we have to see from where we are getting the proper data set for research. So lung images, if we are working on biometric based analysis. Okay, so different types of data sets in biomedical domain. If we are working on ECG, EEG, or IoT based project, so you can see this. Is it visible to all of you? So, and all of these data sets are completely free. Okay, so you can see this. In a particular disease or on a particular domain, you can get these data sets. Okay. And if you are working in computer vision, so you can see these data sets are also available. Okay. So these are latest domains, latest data sets which are available on IEEE, and all of these are completely free. Okay, you can create a free account on IEEE data port, and this can be used for analytics. So you can see in AI, machine learning, computer vision, and health management. So you can see liver tumor segmentation. So all of these data sets are available. So you can create account on IEEE data port, and there is no need of any IEEE subscription. You can directly download these data sets for research. In addition, if we want to work on any other domain like Android malware, for example, somebody is working in this particular domain, Android malware detection, Android virus prediction. So you can see all of these data sets are completely free. Okay, so all of these links I have mentioned in this presentation, you can follow. Okay, all of these links. If you are working in medical domain, then NCBI portal. Okay, NCBI data sets. So in medical domain, if you want some specific data set like protein structure or genome data analysis, SARS-CoV data sets, and different tools are also available. So you can explore these data sets from these links. I have mentioned all of these links in this presentation. At the end of this session, I will share this presentation to all of you. Okay. Is this visible to all of you? Is it visible to all participants? Kindly confirm.
Yes, sir.
Okay. So you can see all of these links I have mentioned in this presentation from where you can get the data sets. Okay. Now, after collection of the data sets, what we do? We have to clean it. What is meaning of data cleaning and feature extraction? Actually, what happens in whatever domain you are working, whether it is machine learning or deep learning, if we process our data set directly, if we execute our algorithm directly on downloaded data set, then definitely results will be abnormal and will be very, very bad. You might have seen many times we struck in 67% accuracy. We struck in 68% accuracy or 72% accuracy. Everybody knows that 72% accuracy is not sufficient. 75% accuracy is not sufficient. 75% accuracy means 25% error. Definitely, it will not be allowed. No, nobody will accept that particular prediction. So we have to move ahead to 90% accuracy. In deep learning, we have to move ahead to 99% accuracy or 99.99% accuracy. For this point, we have to work on data cleaning part, data cleaning and feature extraction. For example, we have downloaded this particular data set. Okay. So this is the data set. This data set I have downloaded from same link of IEEE data port. Okay. And first attribute is patient ID. Second attribute, gender, age, weight, died. Whether this person died or not. Okay. So this particular person did not die, 0. This person, this female of this much age and weight, this female died. This was patient ID. Okay. For example, I want to implement machine learning on this data set. Okay. This is my training data set, and for example, this is my testing data set. And in this testing data set, I want to predict what will happen to these people or what may happen to these patients. Okay, so first of all, we should be clear about this point, that using which algorithm, using which model, we have to solve this problem. In case of artificial intelligence, machine learning, or data science, we are having two types of predictive approaches. In broader way, we work on two types of predictive approaches. One is supervised learning and second is unsupervised. When we move ahead to deep learning, in case of deep learning, we work on some additional modules, some additional dimensions like reinforcement learning, self-learning from historical experiences, self-learning from current experiences, from current instances, reinforcement learning. In case of traditional machine learning or traditional data science, we work with supervised learning or unsupervised learning. What is supervised learning? If I want to work with this particular data set, if I want to predict what will happen to this person, okay, male, and this is the age 29, this weight, and I want to predict what will happen. So this will become my testing data. Okay, and on basis of these records, I will train my machine learning model. On basis of these records, this particular data set, I will create a model, and then on this particular data set, we will perform testing. We are coming again to that particular point where we left. Data cleaning. I'm asking you one question. Kindly respond in chat if you know. If you don't know, then you can write don't know or not aware. Okay. This is the data set that we have downloaded from IEEE data port. Patients data sets. This is data training data set, and on basis of these data sets, I want to predict some upcoming values. Okay, I want to predict for this particular person what will happen. First of all, confirm or write in chat whether we can take patient ID in our training model or not. Can we take patient ID as predictive variable? Is it possible to take patient ID in our machine learning model? At the time of creating a model, is there any relationship of patient ID with somebody's death? Yes or no? Can we relate patient ID with somebody's symptoms or somebody's death? In chat only, kindly confirm. There is no relationship. Yes, definitely. There is no relationship of patient ID with somebody's death. We can take gender, okay? We can say that, okay, if this is the gender and this age group, then its model can be created. Its mathematical modeling can be done. Mathematical modeling of age, weight with died, it can also be done. But mathematical modeling of patient ID, PAN, Aadhaar, these can't be done until and unless we are taking numerology in consideration. But in machine learning, in technical machine learning, there is no sense of using numerology. That somebody's bed number, somebody's patient ID, somebody's Aadhaar number, this person was having this Aadhaar number, that's why this person died. So simply not possible. Okay. So what is data cleaning? At the time of creating the model, we have to delete it. We can't take this attribute in prediction. Okay, so this point is very important, and it must be implemented in every research. Whether you are taking CT scan data, ultrasound data, or X-ray data, first of all, that particular data set must be cleaned. And it is also associated with feature extraction. We are taking the selected features. Okay, another point, another thing is also there in data cleaning and data pre-processing, feature extraction, that missing value analysis. Many times data is missing. For example, this somebody at the time of admission in hospital did not mention age. Somebody did not mention their weight, or weighing machine was not properly working. Okay, age was not correct. So this is also key point. Many times we struck in this type of data set where so many missing values are there. Somebody did not mention the weight, or weighing operator was not available. So how to work now? For this type of implementation, for this type of scenario, we have to work on missing value imputation. So in general, what we do, or what is said, that okay, we can remove those records which are having missing values. But what will happen if most of the records are having at least one missing record? Then definitely it will be very problematic for us. Now you can see this, see that if I delete these records which are having some missing value, somebody did not mention their age, somebody did not mention their weight, somebody did not mention their any other attribute, then how to take this particular data set for training. Definitely, we can't remove 70% records in this particular data set. We can't delete so many records from this data set, because after deleting so many records, this data set will be of no use. So we have to work on imputation, data imputation. So I'm directly coming to that particular part. Missing value analysis and treatment with imputation. Somebody did not mention their age. So what to do with this? Okay, some at the time of data collection uh, network scenario, download speed is not fetched properly. Okay, so all of these points are associated with feature extraction, data exploration, data set analysis, and missing value imputation. To work with this particular part of missing value imputation, we work on different algorithms. In Python, there are so many libraries available using which we can impute the data, using which we can impute that particular missing data. Okay, so if somebody did not mention their attributes, okay, then rather than removing that particular data set, rather than removing that particular record, we can impute it. Okay, so in Python, for missing value imputation, we can use missing py package. Okay, first of all, we will see this part, missing value imputation, and after that, we will see regression part, how to work on regression approaches in machine learning, and then we will see different platforms, how to work on different platforms for machine learning and deep learning. Okay, so as far as implementation of machine learning, deep learning, or data science is concerned, we can use different platforms. In general, this framework is used for data science, machine learning, and predictive mining. That is Anaconda. Okay, so you can see, you can download it, individual edition. How many of you are aware with basics of Python programming using Anaconda? How many of you have worked on Anaconda platform? Kindly write in chat. Anaconda, it is integrated with so many packages which we require for machine learning and predictive analysis. So you can see TensorFlow, PyTorch, Conda, all of these we can work. How many of you are aware with Anaconda platform? Kindly write in chat. Is it visible? Is it visible to all of you? So Anaconda is the key platform that is used for machine learning. If we install Anaconda platform, then all of these libraries we can directly work with. Okay, and it is dedicated installation. If in my laptop I want to work with machine learning, if I want to work with deep learning or data science, then we can use it. Okay, second platform that we use, that is Google Colab. How many of you are aware with Google Colab? What is Google Colab? Google Colab platform. In chat, kindly write how many of you have worked on Google Colab. for machine learning, deep learning, or data science. I'm opening this link. collab.research.google.com. Okay, it is a cloud-based service provided by Google for data science, machine learning, and deep learning. It is integrated with GPU as well as TPU, tensor processing unit, graphics processing unit, and tensor processing unit. It is integrated with that. Okay. Uh, when we work with high performance applications, high performance implementations of machine learning and deep learning. For example, I want to work with X-ray data set or ultrasound data set. Okay, in traditional way, our laptops, our standalone systems are not sufficient because in our systems, in our laptops, we use processors, CPU. For deep learning, for machine learning, for high performance computations, we need TPU and or GPU. So if we are working with Google Colab, then GPU or TPU can be used in free with high performance. So I will show you this link. So I'm opening Google Colab. And in this Google Colab, we will run some Python scripts and we will see some implementations. How many of you are aware with Kaggle kernels? Kaggle kernels. How many of you are aware with Kaggle kernels? What is Kaggle kernel? Have you ever worked on this? Kaggle kernels. Any participant who is aware with Kaggle kernel? What is this? Where it is used? In chat, kindly write. If you don't know, you can write not aware or don't know. But I request participants to kindly respond. Yes, dear participants, how many of you are aware with the Kaggle kernels? What is this? Not aware. Kaggle kernels is also used for advanced machine learning and deep learning. It is, so I'm showing you that Kaggle kernels. So kaggle.com/code. So if you want to work with deep learning or machine learning based applications, then either we can use Google Colab or Kaggle kernels. So you can see that GPU and TPU both are available here. And what is another major difference between Kaggle kernel and Google Colab? In case of Google Colab, we can work with Python programming. In case of Kaggle kernels, we can work with R also. R is also integrated with Kaggle kernels. So you can see this. Okay. For data science, for machine learning, for deep learning, We can use either Kaggle kernels or we can use Google Colab. So you can see that R is also available. In case of Google Colab, we work with Python. But here additional programming platform is given. Now one more thing is there that is very, very powerful, which is not available in Google Colab. That is integrated data sets. So you can see data sets on click of this. So I'm opening this link. Is it audible and visible to all of you? Kindly confirm. In chat, kindly confirm, is it audible and visible to all? Because of some network issue, it is disconnecting very frequently. So, so this is Kaggle kernels. So we were discussing about the differences, key differences between Kaggle kernel and Google Colab. In case of Google Colab, we can work with Python, and here you can see that another very effective implementation is that so many data sets are already available. In case of Google Colab, we have to upload the data set. But here you can see if I want to work with a new data set. So on which data set I want to work with, either I can upload, or you can see that so many data sets are already available here. Trending data sets, popular data sets. Okay, without downloading or again uploading it, we can directly work with so many data sets on Kaggle kernels. For example, I want to work with this. So click here and I can integrate it. On click of this, it will be attached with my notebook. Okay. And so you can see that in code. So how to run the code of deep learning or machine learning in Kaggle kernel? So you can see here, new notebook. On click of new notebook, and you will see that it is easier than traditional Google Colab. So you can see that in which language I want to work with, Python or R. If I click on R, then it will give me R platform to work with for machine learning or deep learning. If I want to work with Python, then Python. Okay, and accelerator, GPU or TPU, which I need. For example, I want to work with GPU, so I will integrate it. Okay, or TPU. What is difference between GPU and TPU? And one more thing you will see that is very powerful. So you can see turn on GPU, and now you can see that GPU quota is 42 hours. In case of Google Colab, it is disconnected instantly. Okay, after 24 hours we have to refresh it. But in case of Kaggle kernels, you can see that how much space they are giving me, 73 GB. Okay, and CPU time, you can see GPU storage, how much it is providing to us. And if I want to attach some data set, that can also be done. You can see add data. On click of this, directly we can attach the data set. You can see. So I'm repeating this point, add data. Which data set I want to work with? For example, this fish data set or this data set, add. Okay. Or if I have uploaded my own data set, for example, this credit card data, add. Okay. And you will see how much easy to work with this platform. Okay. This is the data set. So on click of this here, and in case of it is giving us this preview also, preview of this data, and it is giving me path. So this copy, and we can directly use this path here. In case of Google Colab, what we do, slash content slash drive and then slash file name. In case of Kaggle kernel, we can directly use it. Okay, for example, some other data set we have uploaded. Okay, so on click of this, automatically it will give us that preview. If any additional data set we want to attach, like this, okay, add. Now you can see that on in a single click, this data set is ready to use. If I want to see this data set, music data set, this CSV, okay, I will copy this path, this location I will copy, and wherever I want to use it. So you can see that how much it is easy to work with Kaggle kernels. Okay, and it will give that preview also, how much space we are using. Okay, so any of these platforms we can use, either Kaggle kernel or Google Colab. Is this clear to all of you, how to use Kaggle kernels for machine learning or deep learning implementations? In upcoming sessions, you will see different types of algorithms. But up to now, is it clear to all of you? Up to now, is this clear to all of you? How to use Kaggle kernels and how to add the data set with our work. So you can give this file name, okay, my notebook, and add data set, whatever data set we want to attach. So in a single click, it will be attached. So add, okay, instantly that data set will be ready to use. Is this clear to all? Kindly write in chat how to use Kaggle kernels. Kindly respond in chat. Is it clear how to use Kaggle kernels? So if I want to add a new cell, so on click of this, new cell will be added. Similar to Google Colab. Okay. Now one query I want to ask, please reply in chat. Whosoever are aware with that. What is difference between GPU and TPU? So either we use GPU or TPU. What is difference in GPU and TPU? Any reply if you can give. Where we should use GPU and where we should use TPU? Any guess? GPU is graphics processing unit, that is used for graphics, and that is used for deep learning also. TPU is also used for deep learning, but what is major difference between GPU and TPU? Any major difference between GPU and TPU? If you don't know, you can write not aware. Not aware? Difference in GPU and TPU, where we should use GPU and where we should use TPU. Okay, anyway, I'm covering this point. As far as GPU is concerned, GPU is used for deep learning, advanced machine learning, and it is a general purpose processor that is used for high performance applications. GPU. If we are working in TensorFlow, now see this thing very carefully. If I am using TensorFlow, then I must use TPU. TPU is a tensor processing unit. TPU is the customized version of GPU that is developed by Google for TensorFlow to enhance the performance of TensorFlow executions, to improve the speed of TensorFlow execution. GPU is customized and TPU is deployed. So GPU is general purpose. If I want to use PyTorch, then GPU. Machine learning, GPU. Okay. Traditionally, if we are using deep learning, then GPU. If I am using TensorFlow platform, Keras, TensorFlow, then TPU is advisable. Okay. Rather than taking GPU, then we should use TPU. Okay, TPU for TensorFlow if our implementation is related to TensorFlow. If our implementation is done in PyTorch or Theano or scikit-learn or any other platform, any other programming platform, then we can use GPU. But if we are working in TensorFlow, then TPU. Okay, it is a specialized processor developed by Google to improve the speed of TensorFlow. Is it clear to all of you? And TPU is more than 10 times faster than GPU. TPU is more than 10 times faster than GPU. Okay. So if you are using TensorFlow, then TPU will be best. Okay, GPU will also be okay, but it will not give that much speed that TPU will give. Okay, for TensorFlow, TPU, for traditional deep learning, we can use GPU. Now, we will see that implementation we were discussing. Okay, so you can see this is the data set. On this data set, if you want to implement a regression based approach, that is very traditional approach of machine learning. Okay, so this is training data set, and this we will process here in Google Colab. Okay, so either Google Colab we can use, or we can use Kaggle kernels. Okay, so you can see here within Python we can directly upload the data set using this syntax: from google.colab import files. Okay, files.upload. By this way we will get a browse button to upload the file. Okay, and you can see that these two attributes we are taking in consideration: age and weight. We are not taking patient ID. Okay. And on which data set we want to perform prediction? On testing data set, on this particular data set that I have just shown you, that some records we are having for prediction, and we want to predict what will happen to those people. So on Google Colab, you can directly execute this code. Okay, so you can see this. So it's up to you. So as we are working on traditional machine learning approach in Colab, we can directly use this platform. If we want to work with Kaggle, on Kaggle also we can implement it. Okay, so you can see that these are the predictions of different attributes, predictions of different records, which are available in a separate data set. Now you can see how much accuracy we are getting, 71.25% accuracy. If on same data set, we want to implement random forest approach, then how much accuracy we are getting. Okay. Now here from google.colab, import files and files.upload. Now we will upload this file. So using another approach, if you want to see how much accuracy we can achieve, so you can see that in this approach we are getting 97% accuracy using random forest. In traditional logistic regression, we are getting only this much accuracy, 71.25% accuracy. Okay, so this is traditional implementation of machine learning, by which way we can execute it on this platform, Google Colab. Okay, as far as major difference in these two accuracies are concerned, random forest approach works on multiple permutations. This approach works on all probabilities. Okay, so it is fuzzy based implementation. It is more optimized as compared to traditional regression based approach. Okay, so that particular data set we can upload using these two lines, and we can check the predictive value. Okay, now we will see another point. So as far as deep learning is concerned, you can implement it using this platform, using Google Colab also. Okay, as far as deep learning is concerned, it can be executed on GPU based systems or on browser. Okay, browser based. In general, we think that deep learning can be implemented via Python only, or it is best for Python based implementations. But if I want to work on deep learning on a web browser, then how to work on that particular segment? Browser based implementation without GPU. This part. Okay, so one part is this, using Google Colab or Kaggle kernels, we can use deep learning, we can implement it. If we want to use browser based implementation, then we can use TensorFlow JS. TensorFlow JS. So you can see TensorFlow. So TensorFlow is not only specific to Python or R or Theano. It can be integrated, it can be implemented on a traditional web browser. Is it visible to all of you? TensorFlow.org/JS. If I want to work with browser-based implementations of deep learning and machine learning, I will show you its one demonstration. So this I'm opening. Okay, so you can see that this is the source code. It is a traditional JavaScript code. So I will show you one implementation of prediction using TensorFlow JS. Okay, so you can see that this is our training data set. Okay, this is the training data set. Okay, corresponding to 1 there is this. Okay, corresponding to 2 this is the output. Okay, and you can see that in only 20 to 25 lines of code using TensorFlow JS we can work. Okay, for example, if I want to work with this way, so I'm showing you this data set. This is my training data set. Okay, this is input and class. This is the class. Okay, this is the class. Now I want to predict what will be the output of 7 or what will be the output of 29. Okay. So one way is that I will use regression or we will use typical deep learning, but only for this type of classification. We can use browser-based implementation. So you can see that in this HTML code, we have integrated TensorFlow JS, TF min JS. So this is JavaScript variant of TensorFlow. So this file we can download and we can link it with our HTML code. Okay, and you can see that what is which model we are using. It is a sequential model and model.add. So it is dense model we are using, fully connected. Which type of loss and optimizer we are using? Mean square error, SGD, so MSC. Okay, so you can see that without using Python, within HTML itself, we can work. Okay, for example, now I will run this particular code. So you can see that this, for example, I want to execute. Now you can see that I'm not using any server. We are not using any Python. We are using only HTML and JavaScript for TensorFlow. So for 8, what will be the prediction? For 20. So 20 is not given in this particular data set. So in input there is no value 20. Okay, still I want to predict this. Okay, if I want to change this particular data set, for example, I'm taking another data set, just okay, I'm modifying these values. So 2 I'm removing, this I'm removing. Okay, so this value I'm changing. So this input data set we can modify. One corresponding to 1 there is 4, corresponding to 3 there is 8, 4 there is 10, 5. So I'm modifying this particular data set. 18, for example, 20, 21. Okay, and now I want to predict for example, this is 12. It is 9. Okay, now there is no value. There is no 2, there is no value of 3, 4, 5, 6, 7. 7 is not present here. And for example, this is 18. Okay, so we will test for those values which are not available in this particular data set. Okay, so now I want to predict for 2. So final output for 2 will be 7.22. However, 2 is not mentioned here. I want to predict for 13 or 14 or 14. So you can see that. So using HTML code, using JavaScript also, we can work with this scenario. If I want to change the epochs, so you can see epochs is equal to 10. Now in 10 epochs, what will be the output? For 2, this. For 29, this value. Okay, so you can see that in browser also we can work with TensorFlow. Okay, now I'm asking you one question. Please reply in chat if you know. If you don't know, you can reply. You simply write don't know. Why we have not implemented? Why we have not integrated GPU with web browser? Any reason that GPU is not attached here and still it is working? Why we use TensorFlow JS without GPU in browser-based machine learning and deep learning? Any reply? If you don't know, you can write don't know. Why there is no script to add GPU in this browser? Now you can see that we have implemented, we have seen this code of deep learning, of predictive mining, but there is no script of GPU. There is no additional processor, because its reason is that browser do not use GPU. Whether you are using Firefox, Opera, Chrome, browsers are independent modules which do not get affected with any GPU or CPU. Okay, so because of this reason, a specialized version of TensorFlow is released, that is TensorFlow JS, because there is no association of GPU or CPU with a particular browser. Is this clear to all of you? That web browser or HTTP client do not make use of any GPU. Okay, even if GPU is available in your system, even if GPU is there in your laptop, browser will not use it. Browser will not integrate it. That's why there is no impact of any GPU or not having any GPU, because there is no association of browser with that. Is this clear? Up to this point, is it clear to all of you? So using this platform, you can work with TensorFlow JS, and any type of implementation can be done in without using any GPU within this platform. So you can see everything is available. Whatever we perform in Python TensorFlow, same thing we can perform in our web browser using TensorFlow JS. Okay,